Yes, so good afternoon, everybody. My name is Mats Johannesson. I'm from Sweden, down south Sweden, right close to Copenhagen. Well, yeah, as you may know, we Swedes are not allowed to travel yet, not anywhere. So that's the situation. But I'm happy to be here. I've been working for Hirschmann and Belden now for 13 years, uh, and mainly with industrial network design, consulting, and technical solution selling. Yeah, this webinar about industrial cybersecurity, or ICS, will be an introduction to ICS, and it will probably not give us so much new knowledge, but hopefully some aha feelings. More product and solution will come in the next sessions. So first, some short words about Belden. Let's see if this works. Yes, Belden is an old company founded in 1902. So one of the starting projects for Belden was actually to supply Thomas Edison with an electrical cable. That's quite something. Today we are a big global organization, structured as one of the leading solution providers for global industrial industries. And Belden offers also a full portfolio of solution brands, with very many different brands inside our company, like Garrett.com, Lundberg, Hirschmann, Tripwire, ProSoft, whatever. There's a lot of things, but yeah. Today we're going to talk about cybersecurity. So what drives this industry? So discussing cybersecurity issues within the OT cannot begin until we cover some of the reasons why the concern is growing. We need to start look at how OT world became more vulnerable to threats of any kind. And the conversation starts by looking at the benefits of connecting devices and the convergence of IT and OT. And of course, by connecting our factory to the enterprise, we make the gathering of data in real time a reality. Production or manufacturing information can be seen by management in real time. That is really, really important. Also, all the possibilities of remote access gives us ability to service components ourselves at different size, as well as allowing contractors or vendors accessing our platforms to various tasks like firmware updates or whatever. When we think about the convergence, we often only think about the positive side, like voice and data and video, all at the same wire, all leading to reduced cost of infrastructure. So IP benefits lead to what? I will say also it has some consequences. Why is this? What we do not think about is coexistence. We need to exist, both IT and OT. How do these new systems interact with legacy systems? How do IT and OT collaborate when their needs, beliefs, and approaches are often very different? Because of this convergence, there has been a rapid rise in number of connected endpoints or targets in the last few years. And the number will continue to rise almost exponentially. As the quantity of vulnerabilities rise, the number of unfilled security jobs also continue to rise. Now we are talking about jobs, actually. As such, as the unskilled or underskilled staff working in a security role, I mean, 58% of the OT companies survived classify IT as a major issue. Why is that? Another major challenge for the 50% of the companies survived is finding suitable partners and service providers to actually implement the ICS solution. Given that the market for talent is exhausted, this is especially critical if hiring and using external services is not possible. Companies chooses on cybersecurity implementation options are limited. A lot to think about. We can do a lot with a install base we have today, but yeah, by no means this is a complete list, but at least there are some things we can do in a network to migrate threats without spending any or so much additional money. You should be astonished how many networks we've seen and it's out there with default passwords, admin, private, whatever. It's still in use. That is a major, major threat. Another simple security measure is the use of HTTP. Why not enable HTTPS access for devices that support it? And many devices today do. I mean, the banks all over the world have been used HTTPS for many years now. So, okay. Taking a look at some cybersecurity trends based on this graph from the ICS CERT website. I'm going to talk a bit more of ICS CERT later on. We can see first via the red line, a steadily rising sophistication of cyber attacks over the 30 years. As we harden and secure our system, attackers must learn new ways to infiltrate the networks. Conversely, the green line is descending, indicating that the knowledge to carry out these attacks is becoming less important, and new and better tools becomes available. Just Google and you find all the hacker tools in the world. What about the near future? What is coming next? It is vital that we come to the realization that the OT world becomes more familiar to attackers. And they see the impact an attack can have, that we will see more target strikes on our OT environments. Proactively approaching security in year 2020 is beyond paramount. It's really, really important. We will continue to see an increase in, for example, ransomware. This is a quick and easy way for attackers to make some money. It is safe. It is a safe bet that we will see more ICS-specific attacks moving forward. Ransomware like Logic Loco is already designed to target PLCs and controllers from both Schneider and Allen Bradley. We've seen all these warnings. The non-existing monitoring process must be one of the worst things to lose for a factory. Without active network monitoring, it is very difficult to detect suspicious activity, identify potential threats, and quickly react to cyber attacks. The use of intrusion detection systems is not as common in the OT world as it is in IT world. And we have all these different vulnerabilities. There are a lot of them. We need to care about traffic content. Understanding the traffic means managers need to know what type of traffic is going through the networks in order to be able to make informed decision on how to respond on potential threats and on which kinds of traffic to allow and which to filter. This also helps to establish proper segregation and network segmentation. This is an important part. I will close this session today with more information on that. Okay, so this shows the most common threats and the level of importance indicated by the experts. So the threats have been organized according to frequency which they actually occur. In some cases, the level of importance depends on the type of asset affected and the impact. Most of these security experts agrees that one of the most affected assets is an HMI. That is the most vulnerable device in your network. There are also different compliances recommends depending on the location of the plant. Every country has different regulation and compliance with respect to processing and management. It is difficult to talk about it unless you talk about a specific asset. The United States Department of Homeland Security is a cabinet department of the US federal government, which responsibilities in public security and cybersecurity threats roughly compared to the interior of home ministries of other countries. So the European Union agencies for network and information security, the NISA, is a center of expertise for cybersecurity in Europe. And the agency is actually located in Greece. A great source of information is the ICS service. It's the part of the US Department of Homeland Security. These alerts are meant to inform on potential vulnerabilities for different manufacturers. This does not necessarily mean that a fault is directly with the manufacturer, but just about every manufacturer, including Belden and Hirschmann, has been on this alert page. Many systems becomes vulnerable once interconnected. For example, you connect out to the internet, or when using open platforms, whereas prior to interconnection, they existed in closed controlled environment. They were, for instance, a hacker. It is also important to note that many industrial protocols themselves typically have vulnerabilities as they are inherently unsecure. Following the NISA, many countries in Europe are driven by local agencies. We see, for instance, Estonia, we see Lithuania, we see Poland, Sweden. Yeah, everything is local, more or less. But still, the information database is handled by the ICS. Almost unfortunately, information is becoming more and more freely available to download all over the internet. And today, all the vulnerabilities that can potentially compromise IT system are shown here. That is, of course, double-edged. It raises also awareness of cybersecurity for the ICS asset owners and operators. On the other hand, it also provides critical vulnerability knowledge to the hackers. Granted, these white papers show remediation methods as well, but those are only effective if the user is aware of them. Knowledge is key. You need to care about your traffic content and know your vulnerability. Otherwise, if you don't know you're vulnerable, how should you ever protect it? Incidents. So yeah, 51% of the companies survived by, for example, these virus companies like McAfee or these. They did not experience any incident or breach in the last 12 months, for instance, compared with the result a year before. The number of these companies has slightly risen. It is a growing problem. As a result, one can assume that OT, ITS, cybersecurity measures which were implemented over the last year shows significant results. Yeah, but on the other hand, my question is, how many even know that they have been breached or has experienced a problem? How many actually have control of their network content? That could be a problem. Threats can come from many places. It could be accidental, it could be environmental, it could be almost anything. While it is common to equate cybersecurity incidents with hackers and saboteurs, when we analyze statistics, we find that intentional attacks make up only about 20% of the incidents. From that, only about half comes from external attacks. So external attacks is about 10%. The reality is that a vast majority of incidents are unintentional in nature. And of those incidents, almost 50% are caused by faulty devices of software inside the network. This tells us that a major focus on cybersecurity solution should be to help make the facility or plant more reliable and reduce downtime. Look at the internal security and redundancy function. That is most important. In theory, could any of these attacks have been prevented with traditional means, such as a firewall? Probably not. All of these attacks exploited normally trusted entities. There are, of course, many more examples of incidents like black energy or flame or Dugo or whatever they call. But yeah, just look at this. The most successful one was, of course, Stuxnet. So cybersecurity threats. Yeah, threats to the OT environment. It's real, and it will continue to grow. But the question is, why is there still insufficient attention to this cybersecurity? If Ethernet came from the IT world, if Ethernet came from the IT world, why don't we simply deploy the same practices on OT systems? The simple difference is loss of information versus loss of process. For the IT world, the confidentiality is the most important stuff. For the OT world, the availability is on the top. And with loss of availability and integrity comes risk. And that risk can impact safety of the employees as well as the consumer if quality is affected. On top, security. So who has the tougher job, IT or OT? Yeah, we have a lot to do, actually. There is a number of beliefs within the OT world that typically lead to false sense of security. Security by minority, for example, for decades has been the motivation and belief of Apple users. I'm running an Apple device. I am so secure because there is no viruses, blah, blah, blah. The belief that the belief of this, because it is a niche device, it is not vulnerable. But in 2016 alone, Mac OS malware rose with more than 700%, says McAfee Labs. 700%. This, of course, then of course, there is the belief that old system is so old, why would anyone waste the time on that? Yeah, the reality is that the hacker is not targeting networks that are cutting edge networks. They are typically opportunists. They are looking at the least resistant people. I mean, the easy way in. Networks with weak security and security beliefs, along with old operating systems, these are the most vulnerable and therefore easiest targets. Perhaps the biggest mistake and most prevalent, and it won't happen to me scenario, is the air gap. The belief is that as long as there is no connectivity to the outside world, the network or its components are safe. This is a typical example. Stuxnet showed us in epic fashion that there is no truly air-gapped network. So how did ICS become so vulnerable? Well, until the late 80s, control systems were truly isolated from each other and from the rest of the world. The protocols used were designed for performance and low latency. There were no security at all. So during the 90s, the availability of powerful low-cost PCs sparked a bit of revolution that is still happening today. The air gap took hold because the ICS networks, while migrating and modernizing, were still isolated from the corporate networks and the outside world by the air gap. So the introduction of industrial Ethernet and TCP/IP networking meant that the plants could now grow more rapidly in size and complexity. Yeah, as the 21st century rolled in, ICS system became interconnected with business systems for monitoring, as well as data collections and analytics and all you can think of. The rapid growth and constant development caused the entire industrial space to overlook cybersecurity. So while the changes increased, the exposure, the exposed part of the network, the mission critical applications, they were really big threats, and there was nothing to equip the system to handle it efficiently. So here we see a simple example of how potential threats can start and spread really quickly. This is a simplified diagram of a typical control system where some PLCs and sensors are connecting to a control network that is isolated from the main plant network by dual home PCs. And yeah, so the plant network is in turn isolated from the enterprise network by firewalls, and then the enterprise network is isolated from internet by another firewall. If properly configured, the firewall on the plant network will be able to stop cybersecurity threats that origin from the internet or the enterprise. So it shouldn't be any big problem. But what happens if a contractor or maintenance employee from another location comes in with a laptop or anything that has a virus or malware on it? One of the things malware frequently does is beginning to scan the network, looking for vulnerabilities, and especially looking for vulnerable PCs that it can infect. This traffic can overwhelm the network, sapping all of its available bandwidth and everything. The bandwidth shortage can cause critical systems to lose connection. But it also likely to, sorry about that. It's also likely for the virus to find a vulnerable PC somewhere in the plant. It only takes one. So we lose visibility to all our PCs and all our PLCs, and we will probably crush them. Feasibly, we could hold production in a manufacturing plant in minutes. We could even infect other facilities as well as equipment vendors off-site. We also need to consider how a defective network interface in the control network can impact operation. This is from the inside of the system. Misconfigured or faulty device like a NIC card can generate a large amount of broadcast or multicast, potentially generating a network storm. A broadcast storm can quickly have devastating effects on a network. Simply put, one firewall at the top of the building cannot prevent something like this. It will close down the system, just one faulty device. There is a lot of constraints. The cost, for instance, related to the application of security measures is one of the main constraints observed. There is a large difficulty to justify the investment in cybersecurity because the number of incidents have been relatively small, but their potential and likelihood increases as more and more system becomes interconnected. Some other technical constraints: the use of proprietary operating systems or applications makes it more difficult for operators or asset owners to secure their devices or systems. And also, of course, many other devices are used on remote areas and installations such as oil rigs or power substations, or as a result, it's usually hard to access them physically, and even more problems can occur. So to get order in all these handling, we need some standards to follow. The ANSI ISA 99, it defines security guidelines and user resource for industrial automation and control systems. The evolution of this standard is the IEC 62443, with the intention of completing and expanding its capacity for action. This is where we are going. Hirschmann as a vendor is committed to follow and is certified by the IEC 62443 process. All security related information you find at belden.com/security. This is a big part. It's a session of its own. So when we want to start looking at what we actually could do, we could think about start looking at defense in depth, because it sounds horrible, but this is where you should start. Initially, we think of defense. When we think about defense, we think about firewalls at connection points to the outside world. And that is really cool. But is protecting only the perimeter a wise and comprehensive approach? The problem is, of course, with simply protecting our borders with firewalls, is that many issues originate from the inside of the protected environment. Contractors, exchangeable media, mobile PCs that leaves relatively safe, and it's outside of the firewall environment. We must take greater steps to secure our mission critical environments by placing security and detection measures throughout the facilities that we want to protect. The basic principle of defense in depth mean layered protection with various methods used And yeah, the security design should be case appropriate. And what do we need by that? We need to start looking at this simple way to actually follow some parts of the 62443 class, and that is starting with zones and conduits. It's segmentation and traffic control. By creating so-called zones, we isolate traffic to within the boundaries of the zone we create, and then we restrict its flow via the conduit. If traffic has no reason to leave a zone, one zone, it will not be allowed to do it. Thus, migrating is a potential risk for widespread problems. Security zones, these are the trusted boundaries, usually surrounding a process or group of like devices. Doesn't really matter. It's not a fixed statement. You need to create or think about these zones by yourself. That's a good start. Should be good if this works. Sorry. Yes. Conduits acts as the pathways to control the flow of data between the zones. Whether or not traffic is allowed to pass between zones, the traffic is controlled here. If something gonna move from cell 3 to the control room, I'm allowing or at least detecting it in my conduit. Only traffic necessary for operation should ever be allowed to leave the conduit or pass over the conduit. By placing, for instance, firewall at each conduit, we are able to protect the zones with ID intrusion detection. Of course, intrusion detection will be effective if we are notified of a breach. Now to apply the zones and conduits concept to our network as we showed before. First, we need to define the zones. This we need to think about ourselves. What is my important zones here? So I'm doing the definition of the zones. Remember, a zone is simply a group of equipment, usually performing a common function, and they are most commonly located at the same physical area. Once the zones are defined, we need to locate the conduits, the communication between the zones and out to the network. So it is important to identify all the conduits when communication can enter or leave the zone. This is including wireless communication. We need to know it, otherwise we cannot protect the system. So once all the conduits are located, we can, for instance, insert firewalls and configure them to permit only the minimum network traffic that is required for the correct plant operation. Now we can see how our defense in depth strategy would respond to the same incident that we found out earlier. starting with the infected PC from the contractor, for instance. When the infected PC is connected to the network, the virus will spread and just start scanning everything. But the scanning may cause some issues for the devices connecting to this area of the network. However, the firewall in place protecting each conduit into the plant secure zones. So traffic generated by the virus is not allowed to pass through the firewall. So the zones will continue to operate without interruption, even if the plant network is gone. The most important thing here is the addition to, in addition to the blocking of unwanted traffic, the firewalls will also generate alarm messages to notify that the traffic is being blocked. This is critical in allowing us to locate the issue and get some work done, because this is a situation we cannot live with. The other example of the faulty device generating the amount of traffic in the network, it's the same issue. Just as before, the device's network interface fails, it causes a lot of traffic and it chokes everything within that zone. However, the firewall blocks the undesirable traffic from reaching the other security zones in the plant. And again, before, the firewall in the affected zone will generate alarm messages in real time that will alert us to the problem and let us know what happens. Yes. So this is the end of this, a little bit more than half an hour, but yeah, it's the end of the first part of Belden webinar series on industrial cybersecurity, broadcasted by Klinkmann. Next session in end of August, beginning of September, will be touching maintainability, it will be touching switches and firewalls and monitoring, and what actually we could do with some hardware and software and anything. So please do not hesitate to contact any of us in any project. My name is Mats Johannesson and I'm proud to work as a technical resource at the Belden Customer Innovation Center. So now, time for some Q&As. Marco, are you awake?
Yes, I am. Actually, I do have one very small question.
Ah, that's good.
Because in nowadays, as you mentioned, the OT guys and IT guys, they are getting closer to each other. The world is getting smaller on that side. And typically the OT guys, they are not so expert of the IT systems.
Nope.
Now when the OT and IT are closer to each other, how you see that the manufacturers or distributors or anyone should help the end customers on this situation?
Well, it is two very different things. Being an IT technician doing network job or an OT technician doing network job. Because as I said, the IT's most important thing is to protect the data. I mean, whatever happens, they cannot and will not ever lose one bit of data. That is the most important stuff. If they got a threat, I mean, a cybersecurity chief at a major bank, if they got a cybersecurity threat, they will close down all internet connection and close down the system. And it will be down until they got rid of the virus or the malware or anything. Means that no customer of theirs can reach their money for several hours or days. That's a fact. That is not really the process we do in a factory, because if we close the factory, that the most important stuff for the OT is availability.
Yeah.
We cannot close the factory. So therefore, the IT guys are really, really wonderful on knowing everything there is to know about networking. The OT guys, they know everything there is to know about SCADA system. IT guys do not know anything about SCADA system.
Yeah.
OT guys do not know anything about TCP/IP. They need to start learn from each other. What is most important? That is why there is a lot of IT guys who wants to be in cybersecurity. But in fact, there is a big difference between OT cybersecurity and IT cybersecurity. So it's a really tough question to ask. But yeah, it is upcoming. On all my previous seminars I did in both Estonia and Lithuania, I talked a lot about this situation about workcraft and actually students, importance of having new students studying the cybersecurity for OT systems.
Okay, so we will hear more about this in the next two sessions, how to handle this.
Absolutely. I mean, you don't need to be an expert if you have a system today, a reasonably modern system. There is so much you can do with that system that you probably do not know about. It's already included in the system. So yeah, we need to start learning how to use the device, and that is some parts of what I'm going to do in the next session.
Okay, we are waiting for that. Thank you. So thanks for all participants. Please fulfill the forms about this session, and I hope I will see, or we will see all of you in the autumn and many other more. If you know someone, please mention that this should or might be interesting for you. Thank you from my side as well.
Yeah, thank you all. Thank you all.